Hi, welcome to my channel Mathematics Made Easy by Mary MJ. Today we are discussing class 11 chapter 13 limits and derivatives. We are continuing with exercise 13.2. Fifth question. For the function f of x equal to x raised to 100 by 100 plus x raised to 99 by 99 plus etc. plus x square by 2 plus x plus 1, prove that f dash 1 is equal to 100 f dash 0. So what is this f dash? F dash denotes that we are finding out the derivative. So f of x is given here. First we have to find what is f dash x. What is f dash x? So here we have to differentiate this x raised to 100 by 100. That is 1 by 100 into derivative of x raised to 100. What is the derivative of x raised to 100? Derivative of x raised to n is nx raised to n minus 1. So derivative of x raised to 100 is 100 x raised to 99. So we can write here derivative of x raised to 100 is 100 into x raised to 99 plus second term 1 by 99 into derivative of x raised to 99 is 99 x raised to 98 plus etc. plus here 1 by 2 into 2x, that is derivative of x square is 2x plus derivative of x is 1 and derivative of 1 is 0. Then so here 100 getting cancelled, remaining we are getting x raised to 99 plus x raised to 98 because 99 get cancelled plus etc. plus 2 getting cancelled, we are getting x plus 1. So that is f dash x. And what we have to find here? We have to find what is f dash 1. What will be f dash 1? Instead of x we have to put x as 1. So 1 raised to 99, where all x is there, put x as 1. Then 1 raised to 98 plus etc. plus 1 plus 1. And that is equal to how many ones are here? 100 ones are here. So that is here up to this is x raised to 99. So from here onwards 99 terms and plus 1. So total it will be 100. Now second we have to show that 100 into f dash 0 is equal to f dash 1. So what is f dash 0? F dash 0 means put 0 instead of x. So these all terms, if you are giving 0 instead of x, this all terms will become 0. Only 1 remains. So f dash 0 is 1. Now we have to prove the result. So what is LHS? LHS is left hand side is f dash 1 and we are getting it as 100. And what is RHS? RHS is 100 into f dash 0, that is equal to 100 into f dash 0 is 1, that's equal to 100. So what we got? LHS equal to RHS. Therefore LHS equal to RHS, and we have proved the result. Now the second question number 6. Find the derivative of x raised to n plus ax raised to n minus 1 plus a square x raised to n minus 2 plus etc. plus a raised to n minus 1x plus a raised to n for some fixed number a. We have to find the derivative of this. So that is we are going to, this is given as f of x. The given function is f of x. We can write f of x is equal to x raised to n plus a x raised to n minus 1 plus a square x raised to n minus 2 plus etc. plus a raised to n minus 1x plus a raised to n. Now what is f dash x? F dash x is equal to derivative of x raised to n is nx raised to n minus 1 plus a into derivative of x raised to n minus 1 is n minus 1 x raised to n minus 2 plus a square into n minus 2 into derivative of x raised to n minus 2 is n minus 2 into x raised to n minus 3 plus etc. plus derivative of a raised to n minus 1 into x is a raised to n minus 1 and the derivative of a raised to n is 0. Now we have to find what is f dash a because it is for some real number a. So this can be written as, instead of x we can give a, so n a raised to n minus 1 plus a into n minus 1 into a raised to n minus 2, where all x is there we have to replace it by a square n minus 2 into a raised to n minus 3 plus etc. plus a raised to n minus 1, and that is equal to n a raised to n minus 1 plus here a into a raised to n minus 2. So n minus 1 is common. So a into a raised to n minus 2 means a raised to m into a raised to n is a raised to m plus n. Since the bases are same, we can add the powers. Powers means here it will be 1. 1 plus n minus 2 is n minus 1. So a raised to n minus 1 plus n minus 2 into a raised to 2 into a raised to n minus 3 is a raised to n minus 1. If you are adding the powers, we are getting n minus 1 plus etc. plus a raised to n minus 1. Now we can see that in all the terms a raised to n minus 1 is common. A raised to n minus 1 is common, remaining n plus n minus 1 plus n minus 2 plus etc. plus 1. From all the terms we have taken n minus a raised to n minus 1 outside. That is equal to a raised to n minus 1 into, what is 1 plus 2 plus etc. plus n? Sum of n natural numbers is n into n plus 1 by 2. Therefore, f dash a is equal to a raised to n minus 1 into n plus 1 by 2. So that is the derivative of f dash a. Okay. Now next question. 7th question. For some constants a and b, find the derivative of. Find the derivative of. First question is x minus a into x minus b. So let the function be f of x equal to x minus a into x minus b. We have to find what is f dash x. We can apply product rule here. Product of two functions. How to find out the product of two functions? First function into derivative of the second plus second function into derivative of the first. That is equal to x minus a into derivative of x minus b is 1 because derivative of b, that b is a constant, derivative of b is 0 and derivative of x is 1 plus x minus b into derivative of a is 0 and derivative of x is 1. So the answer can be written as x minus a plus x minus b, and that is equal to 2x minus a minus b. That's a derivative of x minus a into x minus b. Second question here, it is ax square plus b whole square. We have to find the derivative of this. How to find out the derivative? Either there are many methods. Either we can expand this. How to expand a plus b whole square? Using that we can expand it and find the derivative. Or we can consider this as a single element, that is ax square plus b. Consider it as a single term. Then if you are finding out the derivative, that is this, let it be f of x. So f dash x is equal to, since it is whole raised to 2, power this term raised to 2, something raised to 2, that is derivative of x square, we know that it is 2x, or derivative of x raised to n, we know that it is nx raised to n minus 1. So here this, consider it as a single term and then raised to 2. So it will be 2 into ax square plus b whole raised to 2 minus 1 into derivative of this inside part, that is d by dx of ax square plus b. So the answer will be 2 into ax square plus b into derivative of ax square plus b. Derivative of b is 0 and derivative of ax square is a into 2x, or 2ax. That's equal to 4ax into ax square plus b. So another way of doing this is by expansion. That is, you can expand this ax square plus b whole square. How can you expand? This is one method. Second method is this one. F of x can be written as, if you are expanding that, a square plus 2ab plus b square, ax square whole square plus 2ax square b plus b square, and that is a square x raised to 4 plus 2ab x square plus b square. Now find f dash x. F dash x is equal to, derivative of x raised to 4 is 4x cube. So a square into 4x cube plus second term, that is 2ab into 2x. Derivative of x square is 2x and derivative of b square is 0. So this is 4a square x cube plus 4abx, which is this itself. If you are multiplying this, we are getting same thing. So in any of the method we can go for finding the derivative. Okay, then third sub question here is, find the derivative of x minus a by x minus b. For that we can go for quotient rule. So what is f dash x? It is denominator x minus b into derivative of numerator minus numerator into derivative of denominator whole divided by denominator square. That is equal to x minus b into derivative of x minus a is 1, because derivative of a is 0, derivative of x is 1, minus x minus a into derivative of x minus b is again 1, whole divided by x minus b whole square, and that is equal to x minus b minus x plus a whole divided by x minus b whole square. X and minus x getting cancelled, answer will be a minus b by x minus b whole square. Now question number 8. Find the derivative of x raised to n minus a raised to n by x minus a for some constant, constant a. So given that f of x equal to x raised to n minus a raised to n by x minus a, we have to find the derivative, means we are supposed to find what is f dash x. F dash x means we can go for quotient rule, denominator into derivative of numerator, that is d by dx of x raised to n minus a raised to n minus numerator into derivative of denominator whole divided by denominator square. Then what is the derivative of a raised to n? That's 0. Derivative of x raised to n, it is nx raised to n minus 1. So we can write the derivatives. So that is equal to x minus a into nx raised to n minus 1 minus x raised to n minus a raised to n into derivative of a is 0 and derivative of x is 1 whole divided by x minus a whole square. And that is equal to, if you are multiplying this inside, x into nx raised to n minus 1, that is nx raised to n minus a nx raised to n minus 1, then minus x raised to n plus a raised to n divided by x minus a whole square. So again we cannot simplify, you can keep it there itself. Now question number 9. Find the derivative of first one 2x minus 3 by 4. So derivative is equal to, derivative of 2x is 2 and derivative of 3 by 4 is 0. So the answer is 2. Then second question, 5x cube plus 3x minus 1 into x minus 1. So what's the derivative? Dy by dx equal to first function 5x cube plus 3x minus 1 into derivative of the second means 1 plus second function into derivative of the first. What's the derivative of the first? Derivative of x cube is 3x square, so 15x square, and derivative of 3x is 3. So you can expand this. So expanding 5x cube plus 3x minus 1, then here plus 15x cube plus 3x minus 15x square minus 3, which is equal to, all the x cube terms we can add, 5x cube and 15x cube, that is 20x cube, plus 3x is plus 6x, and the x square term minus 15x square, and the remaining minus 1 minus 3 is minus 4. Then third sub question, x raised to minus 3 into 5 plus 3x. So dy by dx is first function into derivative of the second is 3 plus second function into derivative of the first is minus 3x raised to minus 3 minus 1, and that is 3x raised to minus 3 minus 3x raised to minus 4 into 5 plus 3x. We can open the bracket. 3x raised to minus 3 minus 15x raised to minus 4 minus 9x raised to minus 4 into x, that is x raised to minus 3, and that is equal to minus 6x raised to minus 3, then minus 15x raised to minus 4. Now next question, question number 4, x raised to 5 into 3 minus 6x raised to minus 9. So first function dy by dx equal to, first function is x raised to 5 into derivative of the second, derivative of 3 is 0 and derivative of minus 6x raised to minus 9. So minus 6 into derivative of x raised to minus 9 is minus 9x raised to minus 10, then plus 3 minus 6x raised to minus 9 into 5x raised to 4, that's equal to 54, 6 nines are 54, then x raised to 5 and minus 10, that is minus 5, then plus, you have to multiply this, 15x raised to 4 and here minus 30x raised to minus 5. Then 50x raised to minus 5 and minus 30x raised to minus 5. So the answer here it will be 24x raised to minus 5 plus 15x raised to 4. Then question number 5, fifth sub question, x raised to minus 4 into 3 minus 4x raised to minus 5. So dy by dx equal to first function into derivative of the second, means minus 4 into derivative of x raised to minus 5 is minus 5x raised to minus 6, then plus 3 minus 4x raised to minus 5 into minus 4x raised to minus 5, that is equal to 20x raised to minus 10. Then multiplying here, minus 12x raised to minus 5 and plus 16x raised to minus 10, which is equal to 36x raised to minus 10 minus 12x raised to minus 5. And sixth question there, sixth one, find the derivative of 2 by x plus 1 minus x square by 3x minus 1. So dy by dx equal to 2 into derivative of x plus 1 by x plus 1 minus derivative of x square by 3x minus 1. Separately we have to find the derivative. So 2 into, here we have to use quotient rule. So denominator x plus 1 into derivative of numerator is 0 minus 1 into derivative of x plus 1 is 1 divided by x plus 1 whole square, minus, again differentiating this side, denominator 3x minus 1 into derivative of numerator is 2x minus x square into derivative of denominator is 3 whole divided by 3x minus 1 whole square. That is equal to 2 into this, it is 0, then minus 2 by x plus 1 whole square minus, here bracket opening, 6x square minus 2x minus 3x square divided by 3x minus 1 whole square, and that is equal to minus 2 by x plus 1 whole square, then minus 6x square minus 3x square is 3x square minus 2x whole divided by 3x minus 1 whole square. Then next one is to find using first principle. 10th question is find the derivative of cos x from first principle. And what is first principle method? F dash x is equal to limit h tends to 0 f of x plus h minus f of x divided by h, and that is equal to limit h tends to 0 f of x plus h is cos of x plus h minus cos x by h. Now apply that identity, cos a minus cos b, and that is limit h tends to 0 minus 2 sin a plus b by 2, so x plus h plus x by 2, or that is 2x plus h by 2 into sin x plus h minus h, that is sin h by 2 whole divided by h. So again what you have to do, we have already done that sin x result, derivative of sin x using first principle, there we took this 2 to the denominator and there it become h by 2. So this is minus sign can be taken out, limit h tends to 0, sine of 2x plus h by 2 means it is x plus h by 2 into sine h by 2 divided by h, this 2 also I am taking to the denominator, because if it is taken this 2 actually it is here, if you are writing here also no problem. Now if you are taking the limit, the sine h by 2, limit h tends to 0, sine h by 2 by h by 2 is 1. Then remaining minus, separately we can give the limit, h tends to 0, sine of x plus h by 2 into limit h by 2 tends to 0, sine h by 2 by h by 2. And this side, this part, it is 1. So the answer will be minus sine x, because if you are giving h as 0, remaining the answer will be minus sine x. Now the last part of the question, that is question number 11, find the derivatives. Find the derivatives of the following. In that first question, sin x cos x. So how to find out the derivative? F dash x or dy by dx equal to first function into derivative of the second. Derivative of cos x is minus sin x plus second function into derivative of sin x is cos x. And the answer will be minus sin square x plus cos square x, which is equal to cos square x minus sin square x, and that is equal to cos 2x. Then second question, find the derivative of sec x. So f dash x equal to derivative of sec x is sec x into tan x. This all we can find using first principle. Then third question, f of x equal to 5 sec x plus 4 cos x. So find the derivative. So dy by dx is equal to derivative of sec x is sec x into tan x plus derivative of cos x is minus sin x. So minus 4 sin x. Then fourth question, derivative of cosec x is minus cosec x into cot x. This all the standard result we can find out using first principle method. Then next one is f of x equal to 3 cot x plus 5 cosec x. If it is asked in first principle method, we have to do using that. Otherwise, directly we can write the answer. Equal to 3 into derivative cot x is minus cosec square x plus 5 into derivative of cosec x is minus cosec x into cot x. So the answer is minus 3 cosec square x minus 5 cosec x into cot x. Then sixth question, f of x equal to 5 sin x minus 6 cos x plus 7. So f dash x equal to 5 cos x plus 6 sin x, derivative of 7 is 0. Then question number 7, f of x equal to 2 tan x minus 7 sec x. So derivative of f dash x, that is f dash x equal to 2 into derivative of tan x is sec square x minus 7 sec x into tan x. Derivative of sec x is sec x tan x. So thank you for watching my video. Those who haven't subscribed, please like, share and subscribe, and also click on the bell icon for more updates and notifications. Bye.